So we're going to talk about the double slit experiment for light and how we can change the way that the double slit looks by changing some of the parameters of the experiment. If you have not watched the YouTube video that is called the double slit experiment, you need to make sure that you do that first. It's the one that looks like this, and it was also linked in the playlist. So make sure that you watch this one first. The first thing is what happens with the double slit experiment is there are two properties of light that happen at the same time, and they're both wave properties. And so the first one is diffraction. As a review, diffraction is whenever you've got waves of some kind going through a small opening, like so. When they go through, instead of creating perfect lines like this, like a particle would, it actually creates arcs like this. And it has to do with a change in speed as it's going through the opening around the edges of the barrier. And that's kind of where my picture over here talks about. And so in the bottom image here, the two slits that are on the left, if it were a particle, would create two lines on the screen in the back. But that's not what we see when we put light through a double slit. Instead, these two slits create an array of dots on the back. So if we start with looking at this part of this YouTube video, what you will notice is whenever he adds in that second tennis ball, it creates that pattern. And he was talking about how there's areas with crests and troughs, and it creates a constructive and destructive interference. What I love about pausing right here is on this edge on, you can actually see the areas right here where there is constructive interference. You have crest, trough, crest, trough, crest, trough, crest. And then in between them, you can see these blank spots where those two waves that were created by the two separate balls have been destructively interfering and make them cancel out. So as well as diffraction, we have interference. When we have constructive interference, that's where the crest lines up with crest and trough lines up with trough. This is where we get the bright spots. And then destructive interference is where we get the dark spots. We go back to the video, he actually superimposes, there it is, the double slit experiment with light over the water example. And so you can see that in the areas with constructive interference, you have the bright spot, and destructive interference is where it's dim. So what happens if we change some of the aspects of this experiment? So I'm starting with red light. Red light has the longest wavelength, lowest frequency. If I change this light up to blues and violets, now the wavelength is shorter and it's a higher frequency. And what you notice is over here on the screen, instead of having three wider spots, we now have a faint one here and here, but there are 5 distinct spots. And so shorter wavelengths create shorter spots, which also means that higher frequencies create more spots. We go back down to the red. See again, longer wavelength, larger spots, lower frequency, fewer spots. And so let's write that down. So larger wavelength, which is going to be our red, gives larger spots. And that lower frequency means fewer spots. So if I draw this, here's our opening with our red light far apart. Then over here, we're going to get wider spots. If instead we have our blue or violet light, let's do blue. If they're closer together, like this, they overlap more, and so we get more spots. All right, well, what's the next thing we need to do? Ooh, let's make the slits further apart. All right, let me do like a mid-size wavelength here. So we'll go to green. All right, if these slits are really, really close together, then you see they are very close together, then that means that as they're arcing, they don't have as many opportunities to overlap with each other. And so less overlapping means less spots. But if I pull those further apart, you'll see immediately more spots come in, because if the slits are further apart from each other, there are more opportunities for them to overlap with each other, so you get more spots. All right, so slits further apart means that there is more overlap, and so more spots. So let's bring these really close together in the first example. There we go. So if they're close together, they don't overlap as much, and so we don't get as many spots. But if we separate, then there's more opportunities for these to overlap, and so we get more spots. And then the last thing we need to know is what happens if slits are wider. Let's put the separation back around the middle, and let's start with very narrow slits. And so let's see, we've got 1, 2, 3, 4, 5 very distinct. very, very distinct dots. And if we make these wider, then the wider the slit is, then the less diffraction we see. So you can see they're not arcing as much. And if they don't diffract as much, then they do not create as many. So wider slits, wider spots. So the wider slits, less diffraction, which we're saying is that arcing. And so wider slits, wider spots, which means less spots. Right. Those are the 3 ways that you need to know how the double slit experiment can be changed.